Another session on Karnaugh map. I'm Dr. Roji. In the previous session, we had seen the basics of Karnaugh map, such as grouping, naming the groups, etc., and implementing the expressions using gates. We also saw about the SOP and the POS expressions. The link of the previous video will be given in the description section. In this video, we'll do some problems on the various types of Karnaugh map, and I'll also be introducing you to a new concept, a Karnaugh map with don't care terms. So we'll start with the first title, SOP and POS on the same Karnaugh map. So for this, I'll take a problem. F of a comma b comma c comma d is equal to sigma of 0 comma 1 comma 2 comma 5 comma 8 comma 9 comma 10. So the first question should be, which Karnaugh map can I use? So as I had explained in the previous video, choose the largest number, which is 10 in my case. Find out the binary equivalent of 10. Binary equivalent of 10 is 1010. So I need 4 bits for representing 10. So I should definitely go for a 4 variable Karnaugh map. Right? Okay. Now, I'll plot the terms which are given there. The first term is 0. 0 is 0, 0. The first term is 0, which is 0, 0, 0, 0. The second term is 1, which is 0, 0, 0, 1. The third term is 2, which is 0, 0, 1, 0. The fourth term is 5, which is 0, 1, 0, 1. The sixth term is 8, which is 1, 0, 0, 0. And the next term is 9, which is 1, 0, 0, 1. And the last term is 10. So 1, 0, 1, 0. Right? So we have plotted the ones here. Right? So the remaining terms, remaining boxes should be filled with zeros. So I'll choose another color for it. So 0 here, a 0 here, 0 here, 0, 0, 0, 0, 0, and 0. So first I'll do the SOP expression, right? So I need to form groups, right? So I can link this and this by the method of folding, right? I have ones in all, I'll take the next color. I have ones in all the corners, so I'll form the next group with it, right? And I have an isolated one over here. I'll form a green group. Is that clear? So when I take the red group, as I said, this red group can be projected here in this row and this row, which are the terms that are common. A is 0, A is 1, so A cannot be taken. B is 0, B is 0. So the name of the red group will be what? B dash. Now I'll project the same thing as the column. So in the columns, what are the terms that are similar? C is 0, C is 0. Here C is common. So C, since C is 0, it is B dash, C dash, right? And D cannot be taken because it is different. Okay. Now for the blue group. For the blue group, I'll take the same pink again. I'll project it row wise. Yeah, pink would be good. Yeah, I'll project it row wise here, here. Right, what are the terms that are common? As usual, A is not common, B alone is common. So I'll call it as B dash, right? B dash, and I'll project it in the column wise, here and here, because these are the 4 columns where the 4 boxes lie, right? So C is 0, C is 1. It cannot be taken. D is 0 and D is 0. So D can be taken as B dash, D dash. So that's the name of the blue box, right? And what's the name of the green box? Green group, sorry, a green group. In the green group again, I'll project it row, column wise. Column B, this 0 and 1 are common to both the boxes, right? So I can write it here itself. It is C dash D. Is that all? I should also check the rows. So here and here. Here, A is common. A is 0, A is 0. So A dash, C dash, D. Am I right? So what is the SOP expression? B, B dash, C dash plus B dash, D dash plus, what's the name of the green group? A dash, C dash, D. Okay. Now for the POS expression. So for the POS expression, in this box, I'll just plot the zero separately so that it will be clear for you. 0, 0, 0, 0, and a 0, 0, 0 here, a 0 here, and a 0 here. I think that's all, right? Yeah. Yeah. Now we have to form the groups as usual, as before, right? So as usual, I'll take my red color, right? This is one group. This is one group. Okay. Red I had not taken. And this is another group, the red group. I'll take my blue color. This will be another group, right? We'll name the groups now. My pink color again, project it row wise. In the row wise, A is not common, B is common. So immediately I can name B, right? And I'll project it column wise here because these are the two columns in which all the four boxes are present, right? So C is not common, whereas D is common. D is 0, so I should take it as BD dash. Right, sorry, I made a mistake here. I should not take it as BD dash. I should take it as B dash plus D. Am I right? I'll rub it off here because it is a POS term. So what should be the name of the green group? The name of the green group should be B dash plus D. Am I right? Yeah. What's the name of the red group now? The name of the red group will be here. I'll take the pink color, project it here, this, and this. No column elements will be same because A changes, B also changes. I'll project it in this column, right? Because this is the only column in which all the four elements are present, right? Yeah. What's the name for it? C is 1 and D is 1. How do I write the POS expression? POS expression will be C. POS expression will be C dash plus D dash. Am I right? So I want you to grasp the difference between the POS and the SOP expressions. That's why I'm giving you this extra problem, right? Now for this blue group, right? In the blue group, I'll take my pink again. This is the only row in which all the four elements are present, and they are present in all the columns. So definitely no column element is going to be the same. So this element is common for all the four boxes. What is that name? A is B, A is 1, and B is 1. How will I name it? It is A dash plus B dash. Okay. So what is the name of, what is my POS expression? My POS expression will be C dash plus D dash into A dash plus B dash into B dash plus D. Okay. Now for my implementation part, I'll implement the SOP expression and the POS expression side by side. So what is my SOP expression? I'll rewrite it here. B dash C. I'll expand my page a little. Yeah. Yeah. B dash C dash plus B dash D dash plus A dash C dash D, right? So as we did in the previous case, I'll take the signal lines, right? Yeah. One line for A, one line for B, one line for C, and one line for D, right? And an inverter, an inverter, an inverter, and an inverter, and an inverter here, right? So I'll draw inverters and then I'll draw my lines. An inverter over here, an inverter over here, inverter over here, and an inverter over here. Now I'll name them. This is A. So this is B, C, and D. So I'll draw the lines and then I'll do the naming. This is A dash. This is B dash. This is C dash and this is D dash, right? So A dash, B dash, C dash and D dash. So what's the first element? B dash, C dash, right? So I'll take a connection from here, B dash, C dash, okay? I'll draw an AND gate over here, right? And what's the next one? B dash, D dash, right? B dash, D dash, right? Yeah. And I'll draw a AND gate over here. And what's the next one? A dash, C dash, D, right? A line from here, A dash, C dash, and D, right? Yeah. I'll draw an AND gate over here, right? Now I should combine all these by using an OR gate. An OR gate at the output, right? And lines from here, line from here, line from here. It's not correct, so I'll draw it again. Yeah. So this is my final output expression, right? In the same way, we should also, this is the implementation of SOP. Am I right? Implementation of SOP. In the same way, the only difference will be when you implement a POS will be in the place of sum of products. Yes, in the place of AND gates, you'll have an OR, and in the place of the OR, you'll have an AND, right? So this is how you'll implement the SOP and the POS. And from this same expression, I have got a SOP expression as well as a POS expression. So this type of expressions may be asked in your examinations, right? So I have taken an isolated expression here. An expression f is equal to sigma of 1, 3, 5, 7, 11, right? If this is obviously a sum of products, because whenever sigma comes, we can boldly say that it is a sum of products expression. How do I get the product of sums? Product of sums will be pi of, you just take the remaining elements, right? So obviously 11 is here, so it will be a 4 variable Karnaugh map, right? I can take 0, I can take 2, I can take 4, I can take 6, 8, 9, 10, 12, 13, 14, and 15. Okay. So this is, what are these 1, 3, 5, 7, and 11? They are min terms. Right? What are these? These are max terms. Okay. Okay. So we'll come to problem number 2. Basically, it is problem number 3 because we have seen some subdivisions also in between. Okay, no problem. I'll take this as problem number 2. Right? So in problem number 2, an expression has been given. From this expression should be simplified using the Karnaugh map. Right? This is slightly tricky because in the previous problem, the terms were directly given. Your only job, the terms were directly given. Your only job was to plot it on the K-map. Here, the terms are not given. The expression has been given. From this expression, you should plot, right? So, I have taken separate Karnaugh maps to do the separate analysis here. So, first I'll take f is equal to a dash b, right? F is equal to a dash b. Look, f is equal to a dash b means a is 0 and b is 1. So isn't this the right one? So this complete row will be a dash b, right? So for this complete row, I can plot 1, 1, 1, 1. Am I right? Okay, so the complete row, so I'll take the same thing, I'll plot it here. 1, 1, 1, 1. What's the next one? ABC. ABC is what? ABC is, A is, I'll take ABC. A is 1, B is 1, right? A is 1, B is 1 means what? This whole thing. Am I right? But there is a restriction here. Not the whole thing. A should be 1, B should be 1, C should also be 1. So which are the elements? I can plot only here. Am I right? 1 and 1 here. Is that clear? Right. So I'll reproduce the same thing here. 1, 1, 1, 1 and a 1, 1 here. Are there anything else to be taken? A dash B C, right? A dash B C. A dash B C. What does that mean? 0, 1, 1. So 0, 1. This complete um, row is 0, 1, but we need not do anything fresh because it is already engaged. It is already done, right? And what is the fourth element? A, B, C, D. A, B, C, D is directly given. A is 1, B is 1, C is 1, D is 1. So 1, 1, 1, 1. So now can I incorporate everything? 1, 1, 1, 1, 1, right? So this is the plotted Karnaugh map. Am I clear? Okay. Now I'll do it here. 1, 1, 1, 1, 1, 1. So you can also do it by expanding the expression, but this will be simpler. Is that right? Okay. So I'll form the group now. I'll take another color. This is one group, right? And this is the next group, right? Yeah, this is one group. And this is the next group. Again, I want you to think these 1 and 1 can form a group, but I'm not doing that. I settle on for the largest group. What's the name of my green group? By this time, you should be able to project it along the rows, right? A is 0, B is 1. So when you project it along the column, all the columns will be included, right? You cannot do anything here, right? Because nothing is, C and D are not going to be the same. So what's the name of the green group? The name of the green group is A is 0, B is 1. It is nothing but A dash B. Take the red group. In the red group, again, project it row-wise and column-wise, here and here, here and here, right? In the row, anything is common. A is 0, B is 1. Nothing is common. B is 1. Am I right? So, B is 1 is B. Right? And in the column, C is 1. That is only common because D is different. So, BC. What's the final expression which we get from here? A dash B plus BC. Simple, right? Yeah, A dash B plus BC. Now we'll come to the next term, which was not there in my previous video, which is don't care. So far, we didn't use a term called don't care, right? Because we had taken either 0 or 1, right? What is a don't care? The unspecified minterms of a function. The unspecified minterm of a function is called don't care. Is called don't care. An example of a don't care, because we're not going to do it now, but still I thought it will be better if I give an example. The example is a BCD2 7-segment decoder, right? We all know the BCD, right, has only decimal digits from 0 to 9. That is 0000 to 1001. But if you have 4 bits here, this can go up to 1111. Am I right? This is 9 and this is 15. So the numbers from 10 to 15 are not being used in this BCD to 7-segment decoder. So this 10 to 15 are called don't cares. Don't cares can take a value based on your Karnaugh map. The don't cares can be treated as a 0 or a 1 based on your necessity. Because we know the Karnaugh map, we always go for the biggest group. So when I want to form the biggest group, if my biggest group is in lack of a 1 and if a x is nearby, normally don't care is denoted by x or d. If x is nearby, I'll take the don't care as a 1, right? So the value of x will be either a x 0 or a 1. It doesn't have a specific value, right? So steps to use a don't care. Identify the don't care conditions. First one, as we did in this case, we identify 10 to 15 other don't cares. Similarly, for your program, for your problem also, you have to identify, or else it will be directly given. Since you are beginners, in most of the cases, the don't cares will be directly given. Place the don't cares on the corner map, right? And then, as usual, you group with the don't care. So to make things easy, we'll do a problem using a don't care. So I think this is my problem number 4, right? Problem using don't care. M of A, comma B, comma C, comma D is M of 0, 1, 3, 4, 5, 8, 11 plus don't care is 2, 6, 9, 13, 14. So first I'll plot the mean term. So this M is again what? Mean term, right? First I'll plot the mean term, right? I'll take the black. Zeros, first term is 0, 0, 0, 0, 1, 0, 0, 0, 1, 3, 0, 0, 1, 1, 4, 0, 1, 0, 0, 5, 0, 1, 0, 1, 8, 1, 0, 0, 0, 11, 1, 0, 1, 1, right? Now I have to plot the don't cares. As I said, a don't care will be indicated by the by the letter X, right? So 2, 0, 0, 1, 0 is a don't care, X. 6, 0, 1, 1, 0 is a don't care. 9, 1, 0, 0, 1 is a don't care, right? 13, 1, 1, 0, 1 is a don't care. 14, 1, 1, 1, 0 is a don't care. Is that clear? I plotted the don't cares here. Now I have to group, right? So as usual, I'll take my red pen first, right? I'll form this as a group, my red group, right? And this and this will be my blue group. Is that clear? And yeah, a green group over here. This and this are my green group. Is that clear? And I'll take the black. This will be my black group. Now I want you to understand something. My red group covers all the 4 ones in the first row. My green group also covers. So green group covers this one and this one. Am I right? And the blue group covers this one. Is my red group necessary? No. Because all the ones are covered, my red group I can treat it as redundant. Is that clear? My red group I can, because we don't want more and more groups. What is my only aim? All the ones should be covered, right? So if all the ones are covered, I don't need another group. Red group becomes redundant. So I have only a blue group, a green group, and a black group here, right? So I'll form the name for the blue group. My pink again here, this is the row and this is the row, right? A is not common, B is common, B is 0. So this is B dash. Am I right? This is B dash. And I'll project it column wise here and here. Here C is common, D is not common, and C is 0. So it will be B dash C dash. In the same way, since you have a good idea on grouping, I'll write the final answer. My final answer is A dash C dash plus B dash C dash plus B dash D. I want you to go through it by yourselves and find out whether it's right or not. Right? For your understanding, we'll do another program on don't care. Here a minute difference you can see here. right? So I'm not going to express everything in detail here. I'll just plot, because you know everything. You have to do some self-study now, right? 1, 1. And x's, I'll give a different value, right? Okay. I'll take my a red group, right? I'll take my green, a green group. Sorry, why is this not coming? Yes. A green group, right? And I'll take my black. Yeah. Is my problem complete? You might ask me, no, it is not complete because these x's are left. No, it's not necessary to group all the x's. The x's are just used to help you in grouping the ones, right? The case is no ones should be left uncovered. No ones or zeros should be left uncovered. At the same time, not necessary to group all the x's. The x's can be left uncovered. Am I right? So I'll write the name of the group to just see how we got it, right? The red group has a name, A dash, B dash, and the blue group or the green group has got a name, A dash, C dash, right? So with this, I've come to the end of this session, a session on Karnaugh problem solving using Karnaugh. Hope this is interesting, but this will become more interesting if you solve more problems, right? We'll meet again with another session. Till then, bye.